Hello friends, welcome back to Civil Engineering Study and Construction channel. In video, this is HYSD reinforcement bar or high yield strength deformed reinforcement bar. This is to be used in the construction of RCC isolated column. For RCC construction, the specifications of reinforcement are mainly governed by Indian Standard Code of Practice 456-2000, that is plain and reinforced concrete, and Indian Standard Code of Practice 1786-2008 for high strength deformed steel bars and wires for concrete reinforcement. However friends, in today's this important session, we are going to discuss one of the most fundamental and highly significant structural elements of RCC construction, the isolated RCC column. We will cover in details its functions, types of stresses, shear, bending moments, and also the functions of every reinforcement such as vertical bar, ties or rings, and why L is provided at the end of the vertical bars. Along with this, I will also mention the relevant IS code provisions so that your knowledge remains fully code-based and practical for real field application. So let's go to the main content. First of all, what is an isolated RCC column? An isolated RCC column is a vertical compression member of reinforced cement concrete which transfers the load from the slab, beam or any superstructure down to the footing and finally to the soil. It is termed isolated because it stands alone on a single footing and is not interconnected with other columns at the base. Such columns are most commonly used in residential and small to medium buildings where loads are moderate and spacing of columns is economical. These columns has three main functions. Number one, load transfer. The primary function is to transfer axial loads from the structure to the foundation. Loads may be dead load, live load, and sometimes wind or earthquake induced forces. Number two, resisting stresses. A column is not subjected to axial compression alone. In reality, due to eccentricities and frame action, it also experiences bending moment and shear force. Number three, structural stability. Columns hold the building upright. A failure of a single column may endanger the stability of the entire framed structure. Now going to the stresses acting on a column. Number one, axial compression stresses. Direct vertical load causes compression to the column. Number two, bending stress or moment. Due to eccentric load or lateral forces like wind and earthquake, bending moment is developed. IS 456-2000 defines limits of slenderness and eccentricity. Number three, shear stress. Columns resist shear mainly at their junction with beams and footings. IS 456 clause number 40.1 specifies shear strength consideration. Number four, torsional stress. It is not common in isolated columns, but it may occur at beam column joints. Friends, here the workers are making the reinforcement cage for column by binding the ties with the longitudinal bars. Friends, now I am stating you the Indian Standard Code of Practice 456-2000 what stated for columns in the specification. It stated, number one, minimum cross-sectional size of the column should be 200 mm by 200 mm. Slenderness ratio. Effective length divided by least lateral dimension should be less than equal to 12 for short column. Beyond that, it will be treated as long column. Minimum steel reinforcement should be 0.8% of gross area. Maximum steel equal to 6% of gross area but practically kept around 4% to avoid congestion. Eccentricity. Minimum eccentricity equal to L by 500 plus D by 30 subjected to not less than 20 mm. Now the function IS specification stress and moment resistance of different reinforcement components of a RCC column. Vertical bars. Its function is to carry axial load and bending moments. They provide the main strength of the column. Its specification: minimum 4 bars in rectangular column and minimum 6 bars in circular column. Diameter not less than 12 mm. Stress and moment resistance. They resist compression stresses mainly, but when eccentric loading occurs, they also take tensile stresses. Work together with concrete, which resist compression under combined action. Friends, we provide L shape at the end of the vertical bar. But why? Because these are continuity reinforcement provided to anchor the column bars properly into the footing. The L bend ensures bond and prevents slippage under heavy axial compression and uplift forces. IS provision says development length must be satisfied as per IS 456 clause number 26.2.1. They transfer load safety from column bars into the footing concrete. It prevents shear and bond failure at junction. Next item is ties or rings, that is lateral tie. Its function is to hold the vertical bars in position. It prevents buckling of longitudinal bars under axial compression. It provides confinement to the concrete core, enhancing its ductility and strength. Specification: diameter not less than 6 mm for longitudinal bar up to 32 mm dia. Spacing: least of 16 into dia of smallest longitudinal bar, 48 into dia of the bar tie bar, and least lateral dimension of column, that is least of these three. Stress and shear resistance. It resists shear stresses at beam column junctions. Confinement effect enhances strength under axial plus bending plus seismic loads. Friends, I am again stating once again the shear, moment and stress in summary form. Number 1, vertical bars. It resists axial compression plus tensile stress due to bending moment. L-shaped bars at footing ensure bond anchorage and stress transfer to the footing. And tie or ring prevent buckling, resist shear and provide confinement during seismic action. So friends, this was a complete explanation of the isolated RCC column, its functions, stresses, moments, shear and reinforcement detail with IS code specifications. I hope this detailed discussion helps you in both theory and practical field application. If you liked this session, please don't forget to like, share and subscribe to Civil Engineering Study and Construction. Also press the bell icon for more such informative video. Thank you for watching this video. Meet you again very soon with such type of video in the next class. Thanks.